Hey guys, today we are going to start by reviewing sequences a little bit, and then we are going to extend that to finding an expression for the nth term of a sequence. So first, find the sum of the first 34 terms in the series. Anytime we're finding a sum of a series, we are using a formula that starts with S sub n. Now we have to decide if this is going to be arithmetic or geometric. If it's alternating signs, it's probably going to be geometric. So we can try 4.8 divided by -2 and -11.52 divided by 4.8 and see if those are going to be exactly the same. So 4.8 divided by -2 and -11.52 divided by 4.8, and we get -2.4 both times, so we have a common ratio of -2.4. Okay, so we are doing a geometric series, and we are finding the sum of the first 34 terms, so that's A1 minus A1 times r to the n power divided by 1 minus r. Okay, so we'll head to the calculator and we'll put the numerator in parentheses. When you are raising a number to a power, if there's a negative there, you must have parentheses that include that negative and then close before the power. Okay, so there's our entire numerator in parentheses divided by the denominator also in parentheses. And we get about 4.97 times 10 to the 12th power. Okay, the sum of the first 83 terms. So again, we're using an S sub n for the sum of a series. And this one looks arithmetic to me. -111 minus -119. And -103 minus -111 should both be the same. I missed a minus there. And they're both 8, so we have a common difference of 8, so that means this is arithmetic. So the sum of the first 83 terms is n over 2 times the first term plus the last term, which will be term number 83. So I actually have to find term 83, and that is found by doing the first term plus the common difference times n minus 1, so that's 83 minus 1. So 537 goes here. And the sum of the first 83 terms is 17,347. And I just kind of ran into my next problem, so I'm actually going to erase the very bottom of that. Find the next three terms. So x to the 5th, x to the 9th, x to the 13th. What's actually happening here is we are multiplying by x to the 4th power, which means I'm adding 4 to every exponent. So I'll have x to the 17th, x to the 21st, x to the 25th, and then I want the value of term 29. So term 29 equals, and I'm doing this as a geometric sequence. We could do arithmetic just considering the exponents, and then make sure we have an x to whatever that power is, the 29th term. I'm doing this as geometric though, so I've got my first term times r to the n minus 1 power, so that's 29 minus 1 power. So that's x to the 5th times x to the 4th to the 28th power. Now when I raise a power to a power, and I have to do this first by order of operations, I take care of that exponent. I multiply those exponents, 4 times 28. So I have x to the 5th times x to the 112th power. And when I multiply x to the 5th by x to the 112th, I add the exponents and get x to the 117th. Now we are going to write an expression for the nth term of a sequence. This sequence looks like plus 3, plus 3, plus 3, so I've got a common difference of 3. So I'm going back to the a sub n formula for an arithmetic sequence, and that is the first term plus the common difference times n minus 1. So I can distribute the 3, 7 plus 3n minus 3. And I can combine like terms. 7 minus 3 is 4. So a sub n equals 3n minus 4. So that should be plus 4. 7 minus 3 is positive 4. So if I want to know the value of any particular term, I can plug in the term number. The 70th term would be 3 times 70 plus 4. Okay, this one to me looks more like it's going to be geometric, so 5 divided by 2, 12.5 divided by 5. If those are the same, then I'm right, it is geometric, so 5 divided by 2 is 2.5, 12.5 divided by 5 is also 2.5. So since those are the same, I know it's geometric, and I have a common ratio of 2. So I will use the geometric formula. A sub n equals the first term times r, that should be 2.5 there, not just 2. 2.5 to the n minus 1 power. In order to simplify, I would need to do the exponents before multiplication, and I can't do that exponent because it's a variable, so this is actually the simplified form. So whatever term number I want to know the value of, I put that number in for n, and I'll find its value. And this last one, 13 halves minus 7 is not the same as 19 thirds minus 13 halves. And 13 halves divided by 7 is not the same as 19 thirds divided by 13 halves. So it doesn't really seem exactly like it's arithmetic or geometric. So in a case like that, I'm going to look at the top and bottom separately. In the top, it seems to be going up by 6 every time. So I'll say there's a common difference of 6. In the bottom, denominator, I've got a 1 here, 2, 3, 4. It looks like there's a common difference in the denominator of 1. So a sub n equals, and I'm going to treat the top and the bottom separately. So I'll do an arithmetic sequence in the numerator, first term plus difference times n minus 1, and the denominator, first term plus the difference times n minus 1, and I'll simplify that as much as I can. So I can distribute 7 plus 6n minus 6, and 1 plus n minus 1. So combining my 7 and negative 6, I get 6n plus 1 over, and then 1 minus 1 is 0, so I'm left with over n. I cannot cancel out the n's unless I can do it in all three terms, which I can't, so that is my final answer.